Hello all, welcome back to my channel. Today we will be discussing the chapter Systems of Particles and Rotation, class 11th. So, the first thing that we are going to discuss is center of mass. A rigid body is a body with perfectly defined and unchanging shape. The distances between all pairs of particles of such a body do not change. Center of mass. For a system of particles, the center of mass is defined as that point where the entire mass of the system is imagined to be concentrated for concentration of its translational motion. If all the external forces acting on the body slash system of bodies were to be applied at the center of mass, the state of rest slash motion of the body slash system of bodies shall remain unaffected. The center of mass of a body or a system is its balancing point. The center of mass of a two-particle system always lies on the line joining the two particles and is somewhere between the particles. Motion of center of mass. The center of mass of a system of particles moves as if the entire mass of the system were concentrated at the center of mass and all the external forces were applied at that point. Velocity of center of mass and a system of two particles m1 and m2 with velocity v1 and v2 is given. If no external force acts on the body, then the center of mass will have constant momentum. Its velocity is constant and acceleration is zero. Thus, mv cm equals constant. So, now we'll be discussing about vector product or cross product of two vectors. For unit orthogonal vectors, we know I cap into j cap equals j cap into j cap, which equals k cap into k cap, which equals 0, and I cap into j cap equals k cap, j cap into k cap equals I cap, and k cap into I cap equals j cap. Moreover, j cap into I cap equals minus k cap into j cap equals minus I cap, and I cap into k cap equals minus j cap. The angular velocity of a body or a particle is defined as the ratio of the angular displacement of the body or the particle to the time interval during which this displacement occurs. The direction of angular momentum is along the axis of rotation. It is measured in radian by sec and its dimensional formula is m to the power 0, l to the power 0, t to the power minus 1. The angular acceleration of a body is defined as the ratio of the change in the angular velocity to the time interval. Angular acceleration equals change in angular velocity by time taken. The unit of angular acceleration is radian s minus 2 and dimensional formula is m0 l0 l minus 2. Torque. Torque is the moment of force. Torque acting on a particle is defined as the product of the magnitude of the force acting on the particle and the perpendicular distance of the application of the force from the axis of rotation of the particle. Momentum. The angular momentum or moment of momentum about an axis of rotation is a vector quantity whose magnitude is equal to the product of the magnitude of momentum and the perpendicular distance of the line of action of momentum from the axis of rotation, and its direction is perpendicular to the plane containing the momentum and the perpendicular distance. It is SI unit of angular momentum is kg meter square second minus 1, and its dimensional formula is m to the power 1 l to the power 2 t to the power minus 1. Geometrically, the angular momentum of a particle is equal to the is equal to twice the product of its mass and the areal velocity. Torque and angular momentum are correlated as T bar equals TL bar by dt. If no net external torque acts on a system, then the total angular momentum of the system remains conserved. Axis of rotation. A rigid body is said to be rotating if every point mass that makes it up describes a circular path of a different radius but the same angular speed. The angular paths of all the point masses have a common center. A line passing through this common center is the axis of rotation. A rigid body is said to be in equilibrium if under the action of forces/torques the body remains in its position of rest or of uniform motion. For translational equilibrium, the vector sum of all the forces acting on a body must be zero. For rotational equilibrium, the vector sum of torques of all the forces acting on that body about the reference point must be zero. For complete equilibrium, both these conditions must be fulfilled. Couple. Two equal and opposite forces acting on a body but having different lines of action form a couple. The net force due to a couple is zero, but they exert the torque and produce rotational motion. Moment of inertia. The rotational inertia of a rigid body is referred to as its moment of inertia. The moment of inertia of a body about an axis is defined as the sum of the products of the masses of the particles constituting the body and the square of their respective perpendicular distance from the axis. Radius of gyration. The distance of a point in a body from the axis of rotation at which, if whole of the mass of the body were supposed to be concentrated, its moment of inertia about the axis of rotation would be the same as that determined by the actual distribution of mass of the body, is called radius of gyration. If we consider that the whole mass of the body is concentrated at the distance k from the axis of rotation, the moment of inertia can be expressed as I equal mk square. Theorem of parallel axes. According to this theorem, the moment of inertia of a body about any axis is equal to its momentum of inertia about a parallel axis through center of mass plus ma square, where m is the mass of the body and v is the perpendicular distance between the axes. Thus I equals I centimeter plus ma square. Theorem of perpendicular axes. According to this theorem, the moment of inertia of the body about a perpendicular axis is equal to the sum of moments of inertia of the body about two axes at right angles to each other in the plane of the body and intersecting at a point where the perpendicular axis passes. Rolling motion. The combination of rotational motion and the translational motion of a rigid body is known as rolling motion. Law of conservation of angular momentum. According to the law of conservation of angular momentum, if there is no external couple acting, the total angular momentum of a rigid body or system of particles is conserved. So that's all for today's video. I hope you all enjoyed it. See you all again. Thank you.